I would have definitely said something inappropriate when I was your age. I was much less mature than you guys. We're doing the toolkit review. So we have scientific notation, algebra, graphing, unit conversion, which you aptly named. Give me, hold your hand at eye level. Okay, show me. Put your hand right here. If this is easy for you, you feel good with it, go up. If you feel I don't like it, go down. Okay, most of you kind of mid to high with this one, so we'll just do that like really briefly. How about algebra, formula moving? Okay, mostly mid to highs. How about graphing? We got some lower, some, yeah, I don't know about that. Okay, so this is like check mark. This is like little check, and this is like that. What about unit conversion? some of you are down at the floor. Okay.
Is that like the star question?
The star question is actually scientific notation, really.
What's star question?
Like the crazy difficult one.
I don't think I had that one. I think the car was.
Do you want to do one of those types of questions?
Yeah. Is that one?
Yeah.
Okay.
On the test now.
Let's say, what's something big that burns fuel?
A monster truck.
A monster truck. Okay. Well, how about a rocket? A rocket burns, and we'll say it's a liquid fuel rocket. And let's say it burns, I don't know, I'm just gonna make this up. Let's say 10 to the 5 millijoules. Do a small j for joules. Millijoules of, no, we'll do milliliters. Sorry, milliliters of fuel per minute. If each joule of fuel contains, let's say 3.2 times 10 to the 6.
Okay, thank God.
Thank you, sorry.
No,
If
that's
each
liters.
liter
That's
of
liters.
fuel,
That's liters.
yeah,
Oh, so we're converting it?
yes.
Oh.
If each liter of fuel contains 2 times 10 to the 6, no, we'll do 10 to the 10 microjoules of energy.
Microjoules? What?
Yeah, how much energy? I should put this one on the quiz, right?
No.
How
So
much
this is
energy
exactly this
Yeah.
question?
Yeah.
Joules or millijoules?
does the rocket burn
Microjoules.
in 1 hour? Something like that. By the way, these questions that I put on a quiz like this, the math is always super simple, right? And so what you really should do is you should say, okay, if a rocket burns 2 liters of fuel per minute, and if each liter has 1 joule of energy, how much does it burn in a minute? If it burns 2 liters every minute, and every liter has 1 joule, how much does it burn per minute? Okay, you got a gas tank, right? And it goes down by 2 liters in a minute. How many liters does it go down?
2.
2. And if each of those liters has 1 joule of energy in it, how many joules are you burning per minute?
2.
2. Yeah, 2. Because you're going down 2 liters, each liter has 1 joule, right? How did you get that? What did you do? Math.
Kind of common sense.
You did it without thinking, right? You just did 2 times 1. That's all you did. Simple multiplication. The numbers are crazier, but the process is the same. you just have to turn this into liters and multiply this by the number of joules. You gotta turn that into joules. And then you need to, that's gonna be the energy per minute. And how much would we have to multiply by to get 1 hour? 60. And that's it.
Can we try to do it by ourselves?
Yes, do it. If you're watching the video, pause it and do it. And then I will show the answer. I'll do it on paper.
Times 10. Power 12.
I don't know. I haven't done it.
What is it?
This is micro. Do you guys know what micro is?
Micro's 10 to the power negative 6, right?
Yeah, that's millionth. So 10 to the negative 6.
Pardon?
And milli, what's milli?
10 power to minus 3.
10 to the negative 3,000th. So your first job is to convert that to liters and convert this to joules.
What? Dude, why do you have 10 to the power of negative 3 there again?
Milli is 10 to the negative 3. So let's go through this a little bit. So if milli is 10 to the negative 3, how do I get this from milliliters into liters?
Multiply it by 10.
Jay, go ahead. You're thinking
the
as slowly.
exponents, like you can subtract the exponents from each other.
Good.
So it would be negative 3
Okay.
minus
And Hannah, when I'm multiplying powers, what do I do with the exponents?
So you would add the power, so it should be 2
Good,
times
so
10.
5 plus negative 3 is?
10 powers of 2.
Okay, so that's 2, right? You get it?
Yes.
Okay.
I think so.
So how many liters is this?
2
Kennedy,
10 to the power of 2.
do you know how to do this?
So far, yes.
Okay, so how many liters would this be?
Are we converting it to 2?
Yeah, go ahead. The 2.0 stays the same, right? Times 10 to the power of what? 2.
Yeah.
Makes sense?
So when you go from like milliliters to something like a bigger unit, you minus the exponents, right? That was a good question.
If you're going to a bigger unit, so
Yeah.
the value has to get smaller,
And if like.
and
other
that's
than-
why this is negative. So you just multiply this times that. Because this is like, there's this many liters per milliliter.
Yeah.
So when you multiply, the milliliters cancel out and you're left with liters. But you have to multiply by 10 to the negative 3 to get that.
Wait.
Yes.
How did we go to liters, like from milliliters to liters? Instead
Just
of milliliters to microjoules?
because the only reason we had to do that is because I'm saying if each liter of fuel.
Oh, okay.
Now, if I had said if each like kiloliter, well then you'd have to convert to kilos. So you would do what Oliver was talking about. You would do the 5 minus 3 or whatever, and that would give you the number to multiply by. But this one is minus 3, and it's just minus 0 because you're going to liters, so liters doesn't have a thing. Does that make sense? So we just multiply by this because we're going to the liters, which doesn't have a prefix, so we just multiply by that.
Are you gonna post the video on Classroom?
Can you also post like practice questions on Classroom?
Yes. If you're, do you want to do this
No.
just in case?
No.
Okay.
Just in case, then yeah. Can we do it
If
after we
it
finish this
was,
one?
if you had to
Oh,
convert to
fantastic.
kiloliters, let's say. Let's say you had 2 times 10 to the 5 milliliters. We're doing to liters, right? So we're doing, this is -3 minus 0. But if you had the same thing and you said, let's go milliliters to kiloliters, well, that's -3. What's kilo? 3 plus 3, right?
Oh yeah, 3, yeah.
And this
That'll just be 0.
plus 3, so we're doing, no, because we're doing -3 minus +3. So that's -6. Okay, so you would have to do times 10 to the power of -6. So you do this times 10 to the -6. What would your answer be? Sophia?
Would it be 2 times 10 to the power of -1?
Yes. That's absolutely correct. And that would be kiloliters. And that kind of makes sense, right? Because you're, yeah, good job. Because you're going to a higher unit, so that's a smaller number, right? And that kind of makes sense. Can they see this on the video?
No. Oh, how'd you get -6?
Negative.
So you always take, you take the
Plus.
prefix you know and you
5 minus.
subtract the prefix you want.
Okay.
So we know the -3 and we want the +3. So we do -3 minus 3. That's the power way to do it, if you do it that way. You take the one you know and you subtract the one you want.
Oh yeah, because you went from milli to kilo.
That's right.
Okay.
So we're going from -3 to +3. So we go -3 minus +3, that gives us -6. So we multiply by 10 to the -6, and then 5 and -6. Sophia told us was -1. Yes.
So are you always subtracting the exponents?
But it's only if you go from.
Yeah, if you're going from something you have to something you want, you take the one you have and you subtract the one you want.
So if you went from kiloliters, or whatever it's called, to milliliters, it would be the other way around.
It would be the other way, yeah, it would be 3 minus -3.
But you don't have, you still subtract them though.
Still subtract.
So it's always a minus sign?
Yep.
Okay.
This here is always minus. It's always subtraction.
But if it was
So-
-3 minus 3, then you do -3 plus 3, right?
Let's change this. Let's go. Let's say this was kilojoules, but you wanted to go to, or sorry, kiloliters, and you wanted to go to milliliters. How would you do that? By the way, the prefixes are like this.
Okay, so kiloliter, 10 to the 3, it's 10 to
So 3 minus
3 minus -3, right?
These are the ones you have to memorize.
yeah. 3 minus
So if you're
minus.
looking and you're going, I don't know what the prefix is for each letter, it's
So
this.
3 plus 3.
Can they see
Yeah.
that?
So it'd be 6.
And then once we get the exponent, we add it to
So
that
then we-
exponent, right?
So the answer would be
Say that again,
2
Shia.
times.
Like, so once we like add those exponents together, like the kiloliters and milliliters, like
You're,
it's 6.
it's always
Oh, subtract, like,
subtracting,
but
yeah.
in the end, the
So
answer
this is,
6.
excuse me, this is 3, and this is -3, right?
But
Do I
it's
add them or
minus
subtract them?
Add
You
them.
You add them because it's a there's a
Well,
minus
it
sign
just
in the
becomes
middle.
3 plus 3, doesn't
It becomes adding, but it's always subtraction.
Yeah. But in the
That does
end,
not make any sense.
Well, because the
No,
minus
because
and
it's
minus.
but in the end, do we add the 5 to the 6?
Yeah.
Okay.
You,
It makes sense,
you,
but like it should make sense.
you always subtract. If you're subtracting a negative, yeah, it becomes a plus, but you're always subtracting. So 3 minus -3 is equal to plus 6, right? So
if
what are
that's
we
2
multiplying
times
by?
10 to the power of 6 milliliters.
Good, so you do 10 to the 6. 2 times 10 to the 5 times 10 to the 6 equals what?
We have to add the 5.
Yeah.
We 10 to the 11.
That's right. Milliliters. And that makes sense because you're going from a big unit to a small unit, so the number gets a lot bigger. Right. Now, Holly, you with us? Does that make sense? Kind of, sorta.
Can you just show me how to do the regular questions, right?
This one here?
Yeah.
Yeah, let's do it. Okay, so we got our number of liters, right? And let's go back over here. Okay, so we got a number of liters, and so this is the number of liters that we burn each minute, right? So if each liter of fuel contains this many microjoules, let's turn that into joules because we want it in joules later, okay? So let's convert this into joules. How would we do that? No, just wait.
Wait, what is joules?
Joules is a unit of energy. It doesn't matter.
How do you know it's what's its power?
Zero.
Oh, it's 0.
Yeah, because joules doesn't have a letter in front, right?
Oh, so I mean like grams, right? Grams is also 0.
Exactly. Yeah. But micro is 10 to the negative 6, right?
Yeah.
So we have to multiply this times 10 to the negative 6. So how many joules is that going to be?
So you'd go
10 minus 6. So it's 10 to the power of 16.
10 and negative 6. It's negative 6 minus 0.
So it should be 10 minus 6.
Okay, so let's do this.
It's
It's a good thing for us to go through because when you go to joules, there's no prefix, right? So we have 3.2 times 10 to the 10 microjoules, right? Very nice. And we're going to joules. What's the power of joules? 0. Has no power because it has no prefix, right? So this is 0. What was micro?
Negative 6.
Negative 6. So what's negative 6 minus 0?
Negative 6.
Yeah, negative 6. So we just have to multiply by 10 to the negative 6. That's all we gotta do.
So it's 3.2 times 10.
So
Oh, we have to
what's-
do 10 minus 6 now, right?
Yeah. So this is gonna equal 3.2 times 10 to the 4, and that's just joules. Okay. So it's confusing, it's a lot,
Is that the answer?
but that's the answer, yeah.
Okay.
So then how much does it burn in 1 hour?
Right.
Times it by 6.
Okay, so this is now joules. So we have the liters is this, and we do that every minute. And we have to multiply this by this many joules, because every 1 liter has this many joules in it. Yes, Nahal?
But that says a rocket burns whatever that is
Yeah.
per minute.
Yes.
And the answer is looking for per hour.
Yeah, we're gonna do that. We're gonna do that. We're gonna have times by 60 at the end. You're correct. Yeah, you're thinking ahead. But first we need to find the number of joules in that many liters, right? So do this, put it in your calculator as 2, and you're gonna do your E's or your EXP button or whatever button you use. Does everybody have a button for this?
For the 10 to the power.
Yeah, for the
Yeah.
10th power of. On a graphing calculator, it's second function E's. And you're gonna put 2. And then you go times, because we have to do this times this.
So go times 3.2.
So wait, so is it 2E2?
Yes, 2E2 times 3.2 E4. Depending on your calculator, they're all a little bit different.
It's 200, right?
Yeah, this is 200.
Okay.
You can just put 200 in there if you want. And then you multiply that by this, and you're gonna get 6,400,000, I believe.
Yeah, I got that.
That's the number
That's
of.
a nice number.
It's a nice number, yeah. This is the number of joules. So let me erase this. I'll do it over here. So we're gonna have 2 times 10 to the 2, that's our liters, times the number of joules in each liter. And that equals 6.4 times 10 to the 6, I believe, right? This is the number of joules that the rocket burns every minute. As Nahal said, we need the answer of joules per hour. So if it's this many joules in 1 minute, what do we have to do to get it?
60.
We have to times this by 60 minutes in an hour. And if you just go times 16, you're gonna get 3.8 or so times 10 to the 8, I think. Something like that. So those kind of questions they make you think a little bit, but the math is actually really simple. If you're confused with what to do, like what am I multiplying, just pretend that these numbers are small. Just replace it with something small on your paper. Go like, okay, I have 2 joules and I have 3 joules in each liter, or whatever. And then you'll be able to see what to do with it. And then just replace those numbers with the bigger numbers and then use your calculator. Okay, so that's all scientific notation stuff. I'm gonna pause this video because it's gonna be unbearably long.